Hello, myself I am K. Durga Prasad, lecturer in geology, Nagarjuna Government Degree College, Autonomous, Nalgonda. In economic geology, final year syllabus, economic geology, the hydrothermal process is the biggest one of the topic. It's a hydrothermal process. In this hydrothermal process, totally studied by Lindgren, the scientist Lindgren is make a study on the hydrothermal solutions or hydrothermal process. This hydrothermal solution is not mean that is it a water. It's in a liquid position which is containing the mineral, whatever the massivity and mineral abundancy. Along with that solution, it is known as hydrothermal solution. Means heat liquid which is flowing towards the earth surface. It is having the mineral wealth, I told you, most probably metals like and some of the minerals also. Then we have to discuss that first of all, what is hydrothermal process, how it can be decided, from the what temperatures it will be falls. Suppose you take the magmatic concentration, it is up to the 1500 degrees temperatures to it will falls up to 900 degrees centigrade. As like there is a limitation is there. After that magmatic concentration, this hydrothermal solution is take place. It is totally formed in the acidic rocks. Magmatic concentration is forms in the basics and ultra basic rocks. First, this is important. And hydrothermal process we cannot discuss in a single class. Total topic or total matter we can't take in a one class. Hydrothermal deposition or hydrothermal depositional process, which is classified by the Bettman and modified by the Jensen, even in the first introduction is giving that total the mineral deposition classification is made by Alan Bettman in 1940, and again it's modified by the Jensen. He says that in 1970s. That in the classification only, if we saw that the side headings and subdivisions, we saw that how much biggest chapter is that hydrothermal process, it will be case to know. Then we come to here, we have to divide them into the some parts. Okay, because of that total chapter, we have to divide them. First, its introduction, whatever it may be, said that it's a heat solution in a liquid status, okay, having the 500 degrees centigrade to up to the low 50 degrees 100 degrees Celsius. It's moving towards the earth surface. Then it is forming the mineral depositions or metal deposition. This is known as the hydrothermal solution depositional process. A biggest word we have to use. In that we have to, in book you go through the book, you will face the so much material one by one attached. First one, he gives what is the hydrothermal solution and how it will be classified. Next, he will give how a cavity filling will be done. Cavity means a empty place. How it will be filled with the metal or a mineral. In a paragenesis, it is known as the replacements word, that is the paragenesis. A order it will follow, so a discipline is there. Just like a Bowen's reaction principle, after all when you will face the pyroxene, after that hornblende like this. There will be also not a mineral process, but whatever it may be, there is a discipline is there, there is a order, a specific distinct way is there to the deposition. First always with they are when at the institution where the hydrothermal solution is born with high temperatures, from that it will be moves upside. First it will be having high temperature, so that first we will discuss about the how the cavities and what are the necessities to form the hydrothermal solution depositions. What are the necessities? First, hydrothermal solution should have the metallic content or mineral content to form it, to deposit somewhere. I have a bag, then I will keep somewhere in Hyderabad, whatever it may be, Karimnagar, I gone there. Without I am having bag, what I have to keep there? So that it should contains itself some of the minerals or whatever it may be, metals along with it in it itself. Then it will moves like that. When the falling the temperatures, it will be divided into the two types of deposits again. Means first one is the introduction, second one is how cavity will be fills. It is a different class. In other class we will discuss how a cavity will be fills. It's even the Batman and Jensen's discrimination and Lindgren is given a cavity. How cavity means a empty place, how it will be fills. He takes 3 or 4 pages only for the cavity fill, how it will be fills, not the types of cavity filling deposits. The process of the filling only he given in the book for the 4 pages. Means how much big chapter this you can read. That is one part. After that, cavity filling deposits, how many types? That is one part. But before that, first always high temperature deposits will be formed. Then slowly it is reducing its heat and it's falling its temperature, other deposits forms. When it's totally lost its temperature, there is no reactions are there, no depositions will be formed. Then cavity filling deposits are low temperature deposits. Means they are divided as per their temperature. What that? As per their temperature. At the institution where it is born, it's having the high temperature. What is the limitations of the temperature? 500 degrees to 50 degrees. Total hydrothermal solution temperature. Then 500 degrees to up to the 200 to 50 degrees, they are known as the hypothermal. Suppose I will show the slide. It will better because of it will easily you can understand that, right? You can easily understand when I move it, right? The on basis of the temperature, I didn't write the temperature. What is the temperature limits are there against that deposits? Because of you have to remember one thing. If you see the hypothermal deposits, what is its temperature? Immediately you have to get that temperature. Okay, so that I didn't write, but I write in hypothermal deposits, mesothermal deposits, and here epithermal or telethermal deposits. Some of the rare books are uses the telethermal because of their formed tele means distance. In the distances it's formed, so that they are used that word. Here you don't use that. Better to hypothermal, mesothermal, and epithermal deposits. What is its temperature range? Hypothermal deposits are high temperature deposits. Means when its liquid is with burning temperature with the 500 degrees to 300 degrees. What is the limitation of the hypothermal deposits? 500 degrees to 300 degrees. It is known as the hypothermal deposits, very high temperature hydrothermal deposits. The second one comes to that mesothermal deposition. Meso means medium. That is that grade. What is that? 300 to you take suppose 200 degrees Celsius. 300 to 200, between this temperature, which are formed, these are said and fall in the mesothermal deposits. Which are last one, epithermal deposits. They are low temperature deposits. They are below the 200 degrees to 50 degrees temperatures. Now we can divide them. These three will be divided into the two types. One is the high temperature deposits, hydrothermal deposits. Second one is the low temperature deposits. They are said as the replacement deposits and cavity filling deposits. Replacement deposits always high temperature deposits. Cavity filling deposits always low temperature deposits. I will give you illustration to you. Example. Suppose there is a full mob is there. You have to enter forcefully. There is no place, totally fill up. You have to take a side, you have to remove something. Chairs, gears, every some things are there. You have to remove something and you have to sit there. Okay? Otherwise you will not having the place to sit. Means that need very force, means pressure and temperature. It has to dissolve something and make a empty place first. It will create itself in what happens in the replacement deposit. That word, that's why they are used that replacement. It's replacing itself. Suppose there is a some on bench, some of the student is there. You have to pick him up. Suppose a TV is there on the table. You have to totally remove that and you have to keep it there cooler. Like that. Totally you have to remove it. How much force, how much pressure, how much temperature. You have to dilute it and send it outside. In the solution, it will be melt in a solution. In that place it will be deposits some of the gold or tin or copper or lead or zinc or barite or calcite. These are all minerals and metals are formed due to these hydrothermal deposits. First, replacement deposit. What I said, it will remove that. Suppose you imagine a wall, all bricks are there. Simply a brick which is weak, suppose built by the suppose limestone. Limestone easily dissolvable for the chemical. It will dissolve that brick outside and simply gold will be filled in that place, in the brick place. Wall is just like wall, but the brick is changed, the lime is totally come out, the gold is departed. This process is known as the replacement process. It needs high temperature, 500 degrees to 300 degrees temperature it's need. After that, suppose you come for that downwards, that is the mesothermal 300 to 200 or low level epithermal. They don't have that much pressure or temperature to melt them out and throw them out. I means dissolve himself. What they will say, suppose a weak person is there or a weak thing is there. What is that? It cannot throw it outside or this side. Where is the empty place is there, it will be searched for, it will be sit there or it will be settled there. Means it's not having the power to remove something and forcefully replace things. So that it is known as the cavity filling deposit. Which where cavity means empty place. Where is the empty place? That will be filled with that. Means we have to understand that the replacement deposits are high temperature deposits and that the cavity fillings are low temperature deposits. Okay? But in the books we will be face first cavity filling deposits and the discrimination of the cavity filling deposits. Because of why that will be happens on, because of the only they are the cavity filling deposits are so many types and they are representatives for the this hydrothermal deposition. So that so many types, there are 13 types sometimes. These they are not biggest deposits, but there are so many types, kinds of deposits are so many types. 10, 13 types of deposits are there in cavity filling deposits, but they are low temperature deposits. They will only search the empty places and they will settle down there. That is the, now you understand, hypothermal deposits are replacement deposits, and mesothermal also some much deposits are belongs to the, that is the replacement deposits. All are this. Then we divided now. What are the replacement deposits? They are high temperature, which are the low temperature, they are cavity filling deposits. Cavity filling deposits we will discuss in the later classes after that, because of whatever it may be, it will be discussed first. Okay, but as per the temperature falling, the hypothermal means high temperature deposits means replacement deposits. Yeah, I written here in the bottom you see RR. I typed that. That is the replacement deposits and cavity filling deposits in a small letters, because of I don't want to just want to show that you, right? They are the representation. What is the representation? For the high temperature, replacement is the deposits are the representation. For the low temperatures, cavity filling deposits are the representation, right? Okay, this is I want to just want to keep in your mind. Okay, right? Then types of replacement deposits. When we are entered into the topic seriously, only our intention is today not discuss the cavity filling, only replacement deposits. We want to discuss the only replacement deposit. How many replacement? Here, how many types means no. There is a not a significant importance for the types. Here, only 3 types, 4 types are there. Replacement deposits, but they are biggest department and bigger one and largest deposits. If you suppose if you take with the cavity filling in one hand and another hand replacement deposits are very large deposits and biggest deposits. Okay, comparatively cavity deposits are so many types, but they are the small deposits. Replacement deposits are very few types, but they are biggest deposits. That is the change between that. Here I written the 3 or 4 types. Fourth one, please you ignore for some time. After that I will explain. First you take seriously these 3 types. What is that? Massive ore deposits one, replacement loads one, and last one is the disseminations one. This dissemination word you will face in the magmatic concentrations. It is formed due to the disseminations only, the diamonds are formed, where that the magmatic concentration. But here it is the hydrothermal solution, right? That is the different. This dissemination is different, but the process is same. Disseminating means the process is same, right? The magma is different and the depths are different, the temperatures are different. Okay, right. Now we will discuss that what is the massive ore deposition. For everything in deposition, it will follows a way. It will follows a way. Suppose you think yourself, massive means, suppose a massively means that is the biggest, that is a accumulated piece, we will say that massive. It is a massive. How it will be forms? Massive ore deposits, how it will be forms? This formation method of massive ore deposition is known as the bold phase bold phase progressive advanced method. It is a little much difficult to at a time to recognize or remember this long word. In simple word, it's a bold face progressive deposition. Aggressive, progressive means it is intrusive. Okay, it's having very force because of its high temperature and pressure condition. So that the given name, that process is a bold face progressive height. I kept here. Massive ore replacement deposit. I written upon that. How it will be formed? That all bricks I totally said, that's a bricks you imagine it's a country rock. It's a host rock. Then the fissure is there. From the walls it will be entering, that is indicating that fissure is what indicating? A small channel first it will indicates, right? A small channel it will enters into the rock, and what will be happens when it's having a suitable place in the rock where it will be there, immediately from the fissure to it will spread over whatever it may be available place is there. It's on dependence of its temperature and pressure, it will form a biggest massive deposit, which is shown is in a black color. Means here a black. What first happened? A vein, a fissure is entered from the rocks, that is the walls, from the walls, and in the when it comes to the entered in comes to the center, whatever it may be placed, it is all distributed total ore deposition, and all of that that rock is dissolved, like suppose there may be limestone, dolomite. These rocks are very weak rocks, they can easily dissolve in the acid, right? They will be lift over, right? On place this massive deposit is formed. It is not formed in the cavities, it is replaced, which are earlier there, that material or that rock totally dissolved by this temperature and lift away into the solution, and this vein is extended. You just observe that fissure. By that fissure it will be gone away. But which is metal concentrating here is having the very powerful metals, that is that this is the known as the massive ore deposition. First of all, you remember, in total hydrothermal solution, gold, right, silver, gold, whatever it may be, gold, copper, base metals. In economic geology we will use the word that is the base metal. What is the base metals? Copper, lead, zinc, okay, nickel. These are said in the classification of the economic geology, those are said to be a base metals because of their base for the so many alloys. So many alloys are formed due to this base metals. So many alloys are formed due to this with the combination of these metals, by the copper, lead, copper, zinc, right, brass, bronze, gunmetal, German silver, they are all formed due to. So that base metals and precious metal like gold and tin and nickel, little much nickel, nickel is very less, and barite, calcite, these are all formed due to the hydrothermal process. Here whatever it may be, suppose you think this is a copper deposition or gold deposition, whichever it may be, that is the biggest deposition. The deposit will be very bigger one in the earth, right? That is known as the massive ore replacement deposit. What is this process? It is aggressive. What is this process? Special process is given a name, that is the bold phase progressive deposition. I will go back, right? Here also I written carefully, right? Bold phase progressive deposition against the massive deposition. I written that massive deposition is a deposit formed. Process bold phase progressive, that process is known as the bold phase. And second one, replacement load deposits, right? That is against that loads, whatever. I will explain what is the loads, right? Third one, dissemination, that is the polycentric, how it will be. Each process will give each type of deposition, right? Okay. Each process will give each kind of deposition. That's very important. That's nothing but that. Here, massive ore deposition is caused by the progressive and bold phase, that is known as the bold phase progressive advanced deposition. Okay, that is by its behavior they kept that name, right? Next, this is we observed just now, massive ore replacement deposits, right? Then I will move towards the load replacement load deposition. This load, you remember this load word again and again in geology, in so many chapters after studying the hydrothermal process, when you are discussing the metals and minerals and other processes, they will say that they are formed like a loads, they are formed like a massive, they are formed like a, this load word again and again you will face it. Load means it is formed by the replacement deposit. It's just like imagine just like a road, a four-way road or six-way road, just like a big road, that much wide it will be like. Biggest one, just like that. It will be goes like a road, that is known as the loads, load deposit. How it will be forms? That is the formation. I told you, no, one formation method will be there, process. The deposit is here, load deposit. The load deposit, how it will be forms. Now we will see, as like the massive deposit, how it will be there, right? We will see that. That is the second one, how it will be forms that. Here also, it will enters into the host rock from the walls. Host rocks from the walls. It is the fissure, it will enters into that rocks, and it is little much. It is also high temperature. These three are high temperature hypothermal deposits. First it enters when it is rock is having little much permeable, not totally permeable. Permeability is present, but not mostly permeable. And the pressure also, when it's forming this load deposition, there is not specifically, force is not high. Then what happens? Here two types of deposits are mentioned. Carefully observe that. In innovative way, you have to study everything, because of a normal study is in competitive life not useful. You have to study compulsory in an innovative way. Just we are right, we have to draw like dark lines. Okay, this is the deposition. No, this is not like that. You have to thoroughly study it. In this diagram, one is the fissure in between center. Second one is a massive deposit. Already we studied. Then what is the difference? You observed that in this second diagram, what I am showing, replacement load deposit, there is a dots are there around this massive deposit, distributed in the country host rock. Some of the places, some are there, some is there, some is here. Means what is this? This is when the rock is permeable. First, when it's entered into the rock, that is the hydrothermal solution, entered into the rock, what happens? It will immediately escapes where it is a porosity and permeability is there. You may know the permeability. In first year, there is a porosity, permeability. The words are there. Whatever it may be, if you are forgotten, I will try to make it here in a 2 or 3 words. I will explain you. Porosity means the empty places, pore places in the rocks, hollow places in the rocks. It's known as the porosity. permeability means these hollow places are linked with each other. Means from this one side rock, there are so many hollows are there. They are useless to the groundwater because of when they are linked with each other. From the one side you pour the water flow is there, from other side it will be exist. That is known as the permeability. In simple words, in the hydrology or hydrogeology, they says in hydrogeology, it's groundwater. It's a concern to the groundwater. What he says, the permitting water or a fluid from one side to another side. This property of a rock is known as the permeability. They are, which is consisting the porosity. That porosity is different from permeability. Here the permeability is a normally there. So that first where is the permeable, hollows are there which are available. They are first filled. After that the center one is filled. First one, which one filled? Only by the force they are extended to the distances. Next, which are left one, it is aroundly as a massive, like a load, it is formed in the along with it is extended, not like a massive. Just you see that massive is extended, but it's not like that. It's just like a road. It's extending through the fissure. This is the load deposition, right? In the load deposition, you can found that after that some of the distances also small depositions are there. Small and means not I am showing like this thing. Small. There are the other deposits also. You can find that. That is that dots, the distributions are there. That dot distributions are there. Okay. Then this is the replacement load deposit. When it's entered into a rock, host rock, it will by the fissure. What happens when it will be escape into the permeable rock, and first wherever it may be, there is a little much permeable rock is there. That is the porosity is permeability is there. They settle down in that areas, and whatever it may be remaining one is along with the fissure, it will be consolidates, and it will makes the load deposition. It will makes the load deposition, right? Second one. Then I will move for the third one. There is no hurry actually. There is no hurry. Again we will repeat that. There is no match. No, don't worry. Here, this is the only dots they are given. According to the, which one is second, I showed you load deposition. This is as in the part of load deposition. Really what I am totally discriminated. It is a part of load, sir. No, it's not of the part. Here you observe that the fissure even not given. When it's entered into the rock is supposed to be totally permeable. Totally permeable. When you go to some of the lands, agriculture lands, somewhere what happens, the snakes, as a geologist should know these things. Really how dangerous they are, really. We don't know the permeabilities. So many people are, they are daily, they are roaming in the fields, even though they are attacked by the snakes. Why? The reason is permeability only. Permeability that makes the permeable totally land. There will be a one halo will be there. It is attached to the one halo, and here one halo is there. That side is one halo. If you snake you are seeing that way, you are thrown a stone, it will come from the back side. How? There is a internal link to this pore to that pore. It will come from back side and it will be bite you. Like that, very dangerous. Permeability, just like artificial permeability, that is where you can see the multiple holes on this. When you are gone to the field, it is a very dangerous because of Even the scarpers are not moves like that. Most probably snakes like that. They uses that waste channels that are made themselves. They are not natural. Natural rocks are good. Especially sandstones. Sandstones are have high permeability. After that, some of the there are secondary permeability with limestones. Shale only having the porosity, not permeability. Sometimes extends, sometimes very less times, right? Granite is only fractures having, it's not a, right? Then permeable means totally they are having the link to the one pore to another pore, one empty place to another empty place. Internal links are there to these all drops. We are showing these black holes. They are having the internal arrangement, not we are externally. There it is showing just like a black holes. Those are known as the pores yourself, but it's a permeable area. In this area, when the hydrothermal solution is entered into this position, this kind of rock entered into this kind of rock, this rock is containing the characteristic of highly permeable. Immediately it is entered into a one pore, means one empty place, it will immediately distribute to the just like a channels, just like a canals throughout the rock. Immediately they will flows that all directions, and it will be consolidate like this. It will be consolidate like this total area, right? This is known as the permeable rock. This is known as the permeable rock, where the permeable rocks only these kind of deposits will be found. This is known as the polycentralic disseminations. They are scattered. Actually, dissemination means scattered, but here the channels are most probably permeable. In my thought, it is a permeable, right? Not sandstones. Sandstones are not always here. Limestone, dolomite. These two words we will use that, right? And disseminated. That force is high, so that they are forced that disseminated throughout the rock here. Disseminations means scattering. They are scattered. But how they are scattered? Most probably they are having the permeability, so that is easily scattered throughout the rock. Like this, the disseminations are formed. Now you may understand what is the difference between these three. This is massive ore, known as the bold phase progressive deposition, because of it's having the high force and pressure and temperature, so that it's formed and it's removed the matter, and immediately it's formed a big massive ore, that is known as the bold phase progressive advanced deposition, right? This is one, right? Then this is the replacement deposit. I told you first it will be where it is the scatters around that by the permeable, and next it will be settled down along with the fissure, along with the fissure it will be settles in the Chinto, okay, along with the fissures it will be settled down. Then the next one already we discussed just now, this is the high permeable or whatever it may be rock, throughout the rock the hydrothermal whatever it may be, it is derived, the material will be scattered and the metal all formed, okay. These are the whatever it may be, the replacement deposits are bigger deposits than the cavity filling deposits, but the types are only 3 or 4, but not more types. But then we go for the overshoots, right? Before that, overshoot means they are specially sometimes next I will show you. Total in the rock, one side, specially total a mineral deposit ore will be concentrated. That are spaces specially reserved. Just like some of the things will be reserved. Suppose you will kept your all books in a one shelf only, right? All are some type one shelf only. Like that, the ore shoots means they are enriched with the deposits. Those are known as the in the rocks. They are the ore shoots. Maybe total, not total rock. They are not well in one place. They will be specially they are differentiated, and they will be becomes as that part of the rock is rich with the deposition, that is known as the that is ore shoots. These are known as the ore shoots. The ore shoots are really easy to observe the metals because of they are concentrated one thing. Some all the rock will be sometimes empty. Ore shoots are separately, they are like bunches, some we can found that like that, right? That is the ore shoots, right? These are the types of them. Then I will keep these three which we are divided and studied. You will face in your book, whichever it may be, you take that. Okay, Bangar, as you are in degree patterns, Mahapatro, Girija Bhushan Mahapatro, Mukherjee, right? Whatever it may be, the academic, Telugu academic, every book you can see this diagram, right? For your better understand, you have to understand betterly. I divided them individually and I explained you. Actually, individually I divided and explained you each one. 1 A, B, C. Here they are given that. What is the A? Now you can automatically, you take 2 or 3 seconds, you will say that it is a massive ore deposition. Just now we discussed, right? It's a massive ore deposition formed due to the bold phase deposition process. The second one here, first if I not showed individually, you will be confused. Now you are not confused because of separately, individually I explained you, so that it's become easy. The second one is what? Replacement load deposition is there, right? B, replacement load deposition, right? First it will be disseminated and next the material will be consolidated along with the fissure. Third one, C, that is the polycentric dissemination deposits, which are most probably permeable rocks are there. Like this, now you can distinguish with each other and make a comparative study with these three types of depositions. Now you can't never forget, means it's difficult to forget because of when you are understand thoroughly, you distinguish with each other, a comparative study will be done. It will be, you can remember with so many years because of that is the special, that is the comparability. Comparatively, if you studied with each other, it will be very rememberable, right? Memorable, right? These are all three. I kept to one now. Individually you can see with that. This is the individual. That part only, massive ore. Second part, replacement load deposition. Third one, disseminations. I kept 3 here. This is the dissemination, right? Okay. Next, ore shoots. What are the ore shoots? I am already told you what are the ore shoots. Now, what is the behavior of the replacement deposits? First of all, I told you replacement deposits are high temperature deposits, hypothermal deposits. They are not epithermal deposits, low temperature. They are 500 to 300 high degrees temperatures in the hydrothermal process. Then here two diagrams are given. Both are fissures only, veins, just like a veins. One is a single vein is there, just like it is looking like a fissures in between, that vein is there. Along side is just disturbed, that the ore is there, right? That is the along the fissure, a single fissure is there. The second one is there. What is the diagram? That is the shear zone. What is the shear? For the tectonic movements of the earth, what happens? The shear displacements, small displacements will be taken place, just like a fracture zone, just like a disturbed zones, it will be formed. So that you observe that those are all cut down. Why? This is also replacement deposit fissure. This is also replacement fissure. But when you observed it carefully, this is not disturbed. Because of the shearing nature, this is the shear zone deposit is shown at the A, B, and I written on the top also. When you are studying after the class, when you are going through this again, this class, you take before you, it will be easily understand, because of you observe that diagram carefully. How much it is clear that there is a vein is there? No, it's totally disturbed, right? It's a shear, right? Shear. Sometime multiple ores in the local distribution will be there. In local, immediately they will distribute there and consolidates. How it will be there? Let us see. This is the replacement deposit. That is the local of by fissures. Fissures are there. They are scratched, crossed, and whatever it may be, ore. They indicated that ore is formed. Whatever it may be, there is no shear is there, but they are multiply crossed with the each other, so that they are formed like this, like that. Then we have to discuss some of the host rocks before we going to the this slide. Host rocks, what are they? Most probably I told you, limestones and dolomites, right? They are becomes sometimes they changes the rock properties also. Rock properties also. Then what is the structural features? Those are also changed by the this high temperature deposits, replacement deposits. Like that, suppose pepper salt texture will be maintained by replacement deposits. Pepper salt. When you are gone to a restaurant, there will be two boxes will be there. One is pepper salt, one is some, right? When you one is filled with the salt, one is with pepper salt, right? Means black dots and white dots, like that. High temperature deposits always shows the bigger grains, right? Coarse grained, right? Is the nature of the replacement deposits. When it will be differs with the cavity filling deposit, right? Then because of pepper salt texture is the word also very important for the replacement in anywhere. It will shows the pepper salts like a dots. It will be on skin, it will be dots are there, just like they are give smallpox, chickenpox. Just like I don't want to give allergic examples or illustrations, right? Okay, like that textures and structures will be formed with the replacement, right? This one I given by that carefully here. The hydrothermal deposits totally in the South India, total abundant gold, copper is in North India also, but especially gold deposits are only in the South India, right? In South India, KGF, Kolar and Hatti gold fields in the Karnataka. These are the hypothermal deposits. I here written that. That is the Kolar and Hatti gold fields and Ingaldal copper deposits. These are all belongs to the hypothermal deposits. And mesothermal deposits means little much low temperature. Then you can get the copper there also. In Ramagiri, Andhra Pradesh, gold deposits, there belongs to this same type of mesothermal deposits. And this copper also there, the barite deposits also there, mesothermal. But in the southern parts of India, low temperature deposits, it's not concerned to today's lesson because of it is comes in the low temperature deposits, means cavity filling deposits. They are very few in the South India. They are saying only some of the Anantapuram, Karnoolu, Ganikalva, that is the copper deposits are there in Ganikalva. Anantapuram, some of the along right the edges, border parts are there for that. That is that base metals are available. Here what they are author want to say, that is in southern parts of the India, South India, the hypothermal deposits are having various specification because of we know that total for the India the gold is centralized in the KGF, Kolar gold field, but now the gold is extracting from the Hatti. Kolar is from the beginning it is taking that the reserves are they are becoming weak, so that now the exploitation is going on in Hatti. I visited a few years back. Really in Hatti now it is very now the gold exploitation means mining in our geological language. Mining is going on in the Hatti. Means totally this the Ingaldal copper that is also formed, but and sphalerite. What is the sphalerite? It is the ore of the zinc that is also available in the Tamil Nadu, Arcot district, right? That is the sphalerite deposit. This sphalerite, Ingaldal copper, Kolar Hatti gold, these are all belongs to the high temperature, means replacement deposits. So my intention last I bring you towards that matter, means hypothermal and half of the mesothermal deposits are belongs to the replacement deposits. By that what kind of deposits will be formed? Gold, copper, zinc. Sphalerite means zinc, barite, very highest specific gravity mineral. It's used in the lithophone. The total Rayalaseema is rich here. Gajjalakonda, I written that Gajjalakonda place is having that, right? That type of deposit. Like this, totally we can say that these replacement deposits only today we discuss. Cavity filling deposits are left away because of that is totally so many types of deposits are there. Okay, 13 types of deposits are there. We have to discuss them in one class. We have to discuss it in this class only. Replacement deposit, there are 3 or 4 types. Massive ore deposits, again I am saying. Replacement lodes, second type, and disseminations or polycentric depositions. These 3 types you have to remember. Overshoots you have to better to remember along with this, right? What is the process? Already only you take this only diagram. These 3 will be merged in this. Already the 3 are in the same place. I divided them. This diagram, when you see this diagram, totally you can write the essay on the that the high temperature deposits of hypothermal deposits, replacement deposits. Totally you can write this. Is what process, what deposit will be found. In what process, what deposit will be found. And what process, what deposit. 3 types are there. You can write these 3 types of deposits. Well, no problem, right? This is briefly, that is the in hydrothermal solution deposition. 2 types are main. One is the replacement, second one is the cavity filling. Replacement, today we finished the process of replacement deposition. Okay, now I hope all of you, right, all of you followed my lesson. Right, now I am going to complete and end my lesson. Okay, right, okay, I hope again you are all followed my lesson. Thank you. I am ending my lesson.